Bismillahirrahmanirrahim. Assalamu alaikum, dear girls. This is your instructor Shafaq Nisar, Department of Physics. This is lecture number 23 from chapter number 12, Current Electricity. In previous lecture, we discussed about Wheatstone bridge, potentiometer, and we analyzed some numerical problems. Our chapter has completed now and we are moving towards exercise. So first of all, in today's lecture, we will discuss multiple choice questions. Our first multiple choice question is, 7 resistances are connected as shown in the figure. The equivalent resistance between A and B is option A 3 ohms, option B 4 ohms, option C 4.5 ohms, and option D is 5 ohms. So a circuit is given in the figure. We have to solve it and we have to find out equivalent resistance between point A and B. So in the given figure, we can see that we have different resistances which are connected in different combinations. For that purpose, if we start from R1 and R2, we can see that R1 and R2 is equals to 10 ohms and both are in parallel combination. They are connected in parallel combination. So when we solve R1 and R2 for their equivalent resistance, we will have 5 ohm resistance. Similarly, for R6 and R7, which is on right hand side, when we solve them, both R1 and R7 and R6 is equals to 6 ohm. When we find out equivalent resistance, their equivalent resistance is equals to 3 ohms. We can have the equivalent circuit which is shown in the figure. We have 5 ohm resistance on left side and 3 ohm resistance on right side, and in the center we have 8 ohm resistor. So it is what? A balanced Wheatstone bridge. So when we have a balanced Wheatstone bridge, we will see that no current flows through 8 ohm resistor. So when we solve them, this means we can remove 8 ohm resistance. We will see that we will have 5 ohm and 3 ohm resistance connected in series and other pair of 5 and 3 ohm resistors connected in series. So if we find out their equivalent resistance by solving 5 and 3 ohm resistance when they are in series, we will get their equivalent resistance equals to 8 ohms. So in this circuit, we will have at the end 2 8 ohm resistance connected in parallel. So when we solve both these resistors, when we solve this circuit, we will get equivalent resistance which is equals to 4 ohm. So correct option will be B1, which is equals to 4 ohms. Second multiple choice question is, 3 resistors of resistance R each are combined in various ways. Which of the following cannot be obtained? Option A 3R ohm, option B 2R by 4 ohm, option C R by 3 ohms, and option D is 2R by 3 ohms. So in this statement we have 3 resistors each having resistance R. When they are combined in various ways, we have to find out their equivalent resistance. So first of all, when they are connected in series, their equivalent resistance will be 3R ohms. When 3 resistors are connected in parallel, their equivalent resistance will be R by 3 ohms. And if we have 2 resistors in series and one is in parallel combination with other 2, the equivalent resistance will be 2R by 3 ohm. So correct option will be option B, 2R by 4 ohms. Third one, calculate current in 2 ohm resistor. We have a circuit shown in the figure. We have to find out current through 2 ohm resistor. So option A is 1 ampere, option B 1.29 amperes, option C 0.73 amperes, and option D is 1.43 amperes. We have 3 resistors connected in parallel between point A and B. We have to find out their equivalent resistance, which is equal to 12 by 11 ohms, shown between point A and B. We can see in this circuit we have 3 resistors: 1 ohm resistor, 12 by 11 ohm resistor, and 3 ohm resistor. All are connected in series. So when we find out their equivalent resistance, we will have 5.09 ohm. So we can find out current through this circuit, which is equals to I. From Ohm's law, we know that I is equals to V by R. Here we have V equals to 12 volts and R is equals to 5.09 ohms. By solving them, we get 2.35 amperes. We have to find out voltage across 12 by 11 ohm resistor. So we know that V is equals to IR, I is equals to 2.35 amperes, and R is equals to 12 by 11 ohms. By solving them, we get voltage VAB, that is voltage between point A and B, which is equals to 2.57 volts. In the given statement, we have to find out current through 2 ohm resistor, which is equals to I is equals to V by R. Here we have V is equals to VAB, which is given as 2.57 volts, and resistance R is 2 ohms. So at the end, current is equals to 1.29 amperes. Correct option is B1, 1.29 amperes. Number 4 is 10 power 6 electrons are moving through a wire per second. The current developed is option A 1.6 into 10 power minus 19 amperes, option B 1 ampere, option C 1.6 into 10 power minus 13 amperes, option D 10 power 6 amperes. So in the given question, we have 10 power 6 electrons. This means number of electrons are 10 power 6, which are moving through a wire per second. Per second means we have time. Time is equals to 1 second. And we have to find out current through the wire. As we know that I is equals to Q by T. And furthermore, Q is equals to N into E. N and E both are given. N is number of electrons and E is charge on an electron. By putting the values given in this statement, we get 1.6 into 10 power minus 13 amperes. So correct option is C1, 1.6 into 10 power minus 13 amperes. Fifth multiple choice question is, when a wire is stretched and its radius becomes R by 2, then its resistance will be option A 16R, option B 4R, option C 2R, and option D is 0. In the given question, a wire is stretched. Stretched means its length is changed, and radius also becomes R by 2. We have to find out its resistance. So from the relation of resistance, we know that R is equals to rho L by A, and A is equals to pi R square. So we have rho into L over pi R square. But when wire is stretched, area is changed into A prime, area A, which is changed into A prime. This means now r is changed, radius is changed, which is equals to r by 2. By putting values, we get a prime equals to pi r square by 4. At the end, we have a prime is equals to a by 4. But as wire is stretched, length is also changed. Length is changed, but there is no change in volume. Initial volume is equals to final volume. We know that volume is equals to pi r square into L. But initial volume is equals to pi r square into L, and final volume is equals to pi r by 2 whole square into L1. Because when length changes, let's say that length is equals to L1 or L prime. So when we solve them, L prime will be equals to 4L. By putting this value of A prime and L prime in the relation that R is equals to rho L by A, we get R prime is equals to rho into 4L over A by 4. So at the end we have R prime is equals to 16R. So correct option is A1, 16R. Number 6 is a wire of uniform cross section A, length L and resistance R is cut into two equal parts. The resistivity of each part will be A1 doubled, B halved, C remains the same, and D1 is 1/4. We know that resistivity is the property of a material which will remain unaffected by cutting into two equal parts. So correct option is remains the same. The resistivity of each part will remains the same. Seventh one is the resistivity of two wires is ρ1 and ρ2 which are connected in series. If their dimensions are same, then equivalent resistivity of the combination will be option A ρ1 plus ρ2, option B 1 by ρ1 plus 1 by ρ2, option C ρ1 plus ρ2 whole divided by 2, and option D is ρ1 by ρ2. In the given question, resistivity of two wires is ρ1 and ρ2, and we have to find out their equivalent resistivity. Two wires are connected in series. We know that in series R is equals to R1 plus R2. From the relation of R, we know that R is equals to rho into L by A. In the given question, we have R is equals to rho 2L by A. As in series two resistors are added, so their lengths are also added. We will have 2L. R1 is equals to rho 1 into L by A plus rho 2 into L by A, as R2 is equals to rho 2 into L by A. By solving them for resistivity, we will have rho is equals to rho 1 plus rho 2 whole divided by 2. As L and A are common, so they are cancelled. So correct option is rho 1 plus rho 2 whole divided by 2. Correct option is C1. Eighth one is the power of two electric bulbs are 100 watt and 200 watt, which are connected to power supply of 220 volts. The ratio of resistances of their filament will be option A 1:2, option B 2:1, option C 1:3, and option D is 4:3. In the given question, we have power of two electric bulbs which is 100 watt and 200 watt. Power supply voltage of power supply is also given, that is 220 volts, and we have to find out ratio of resistances of the filament of the bulbs. We know that from the relation of power P is equals to V square by R. From that we can find out the value of R. R is equals to V square over P. According to given question, we have to find out ratio of resistances. So if we have resistance of one electric bulb equals to R and resistance of other electric bulb equals to R2, so their ratio is R over R2. By putting their values, R is equals to V square over P and R2 is equals to V2 square over P2. By finding out their ratio, we know that voltage of power supply is same for both the bulbs. Then V1 is equals to V2. We will have ratio of two resistances equals to P2 over P. P2 is equals to 200 watts and P is equals to 100 watts. By solving them we get 2 by 1. So correct option is 2:1, B1. Ninth multiple choice question is, thermocouple is an arrangement of two different metals. Option A, to convert heat energy into electrical energy. Option B, to produce more heat. Option C, to convert heat energy into chemical energy. And option D is to convert electrical energy into heat energy. Correct option is to convert heat energy into electrical energy, option A, due to the reason that we know that thermocouple is a source of current which converts heat energy into electrical energy. So thank you girls. This is the end of today's lecture. Hope each and everything is clear. Allah Hafiz.